All right, I want to talk about the F curve here on this problem, 7.376. When we're doing ANOVA, we are using a new distribution. It's not our normal distribution, and it's not our T distribution. It is an F distribution. And we don't know too much about this, so I wanted to make a couple graphs for these problems to kind of go along with these problems and talk about their critical numbers and the probabilities that we get those critical numbers. So anyway, here's my first graph. I've got my degrees of freedom, which is 5, right? And I've got my degrees of freedom based on the residuals, which is 65. This has all been computed for me, right? Let's say I had a critical number, an F value, that was like 0.1. So that if the F value had been 0.1, it would be this number. If we had done a right-tailed test, right, the probability that we would get 0.1 or greater would be 0.99, and we'd compare that to our alpha, and we'd probably, fail to reject our null hypothesis. But here, our critical number is actually 15.36, so it's 15.36. You can tell down here that 15.36 isn't even listed, so it's like going to be way over here somewhere. And the probability that we get a critical number of 15.36, or the test statistic of 15.36, is basically 0. 15.36. There we go. Yep. So the way that we find our critical number is just the F value, because it's the F distribution that we're looking at. And the probability that we're bigger than that F value is listed right here. Let's go ahead and do the same thing again for a different problem. Here's problem 7.0. This has all been computed for us again. So here's our degrees of freedom is 7, right? And the degrees of freedom based on the residual is 189. So here's what our F distribution looks like for these degrees of freedom, right? Oh, it tells us all that fun stuff. The F value here is 1.87, so 1.87. And that's right here, and the probability we get bigger than 1.87 is 0.07656, and that's the same probability that we have here, although, oh, it's almost the same. Anyway, the reason it is about almost the same is I imagine this number is rounded, and they're computing it with a not rounded number, and so when I compute it with a rounded number, I get a slightly different probability. That doesn't matter too much because you'd be using this probability anyway, and you'd be using the probability that Excel spits out for you. All right, so that's kind of explaining where our test statistics are coming from. They're just the F value, and our probability that goes with it are just this probability here that's listed. All right, thanks.